So, how do you teach a machine to think? Not just to calculate, but to actually reason? Well, that's what we're diving into today. We're going to look at something called first order logic. It's this super important idea from the early days of AI that basically gave computers their first real taste of logical thinking.
I mean, that was the big problem for the early AI pioneers, right? They had these amazing machines that could crunch numbers like nobody's business. But so what? The real trick was, how do you teach a computer basic common sense? How do you get it to understand simple stuff about the world and, connect the dots? That jump from just calculating to actually reasoning, that was everything. Okay, so here's our game plan. We're going to start with that big picture, the quest for reasoning. Then we'll zoom in on the solution, which is first-order logic, and break down its toolkit. We'll even see it in action, like an AI's first thought. And then we'll pull back out and look at the huge impact it's had. Let's do it. All right, first up, the quest for reasoning. To really get why first-order logic was such a big deal, you gotta understand the jump AI was trying to make. This was never about building a faster calculator. Nope. It was about creating something that could actually, conclude? And to make that happen, a computer needed some kind of formal system, a rule book, basically. A way to understand facts about the world, simple things like birds can fly, and then use those facts to figure out new things. It had to be able to map out how the world works, which is way more complicated than just numbers in a spreadsheet. Take a look at this. All humans are mortal. Socrates is a human. Therefore, Socrates is mortal. To us, it's totally obvious, right? But think about it from a computer's perspective. It's a massive puzzle. It has to get what all means, what human is, what mortal is, and how they all connect logically. This little sentence, this is exactly the kind of thinking that AI had to learn how to do. So, how do you teach a machine to solve that puzzle? Well, researchers knew they needed a brand new tool. They needed a language for logic, a super strict grammar for thinking, something a computer could follow to the letter with zero confusion. The first shot at this was something called propositional logic, and it was okay for a start, but it was kind of a blunt instrument. It could look at a sentence like, "It is raining," and just say true or false. That's it. It couldn't dig any deeper. It had no idea what was raining or where. It just didn't have the detail. And this is where you can really see the massive leap forward. With propositional logic, a fact like Socrates is human is just one big chunk, one label. It can't be broken down. But first-order logic, or FOL, is way smarter. It sees the world differently. It understands that Socrates is a thing, an object, and being human is a property of that thing. And that one little change, the ability to talk about objects and their properties, that was an absolute game changer. Okay, so now we're getting to the good stuff. Let's pop the hood on first-order logic and look at the actual tools inside. This is what gives it all its power. The best way to think about it is like a grammar for reasoning. It's a perfect analogy. Just like our language has nouns and verbs and all that to help us build sentences, FOL gives an AI the basic pieces it needs to build logical thoughts about the world around it. First up, you have objects. These are basically the nouns in the AI's world. We're talking about specific things. Socrates, a house, a cat. These are the individual items the whole system is going to reason about. Everything starts with the objects. Okay, so if objects are the nouns, then the next part, relations or predicates, are the verbs and adjectives. These are the words that describe what the objects are or what they're doing. They can be simple properties, like saying Socrates is human, or they can connect multiple objects, like the cat is on the mat. This is what makes the AI's world dynamic. And now for the real magic ingredient, quantifiers. This is the part that lets the AI think big. It can go from talking about one specific thing to making a rule about everything. You've got for all, which lets it say something true for an entire group, and there exists, which lets it say that at least one thing has a certain quality. This is how you build a rule like, all humans are mortal. Okay, so we've got our toolkit, objects, relations, and quantifiers. Let's put them to work. It's time to see how an AI uses these pieces to actually think. And this is it right here. This is the moment. So first, the AI gets a general rule. For all things, if that thing is a human, then it is also mortal. Got it? Then it gets a simple, specific fact. Socrates is a human. Now watch what happens. The AI takes that big rule, applies it to that one little fact, and bam, it draws a brand new conclusion all by itself. Therefore, Socrates must be mortal. That's it. That's machine reasoning. It's an AI's first thought. Now, this wasn't just some cool academic exercise or a neat party trick. This ability to reason logically had a huge, lasting impact. This stuff became the backbone for some really important AI systems for years and years.
And this is where it gets really interesting, because this stuff showed up everywhere. We're talking about expert systems in medicine that could help a doctor figure out a diagnosis, or robots that could use logic to plan out the steps to build something. Even when you search a database today, the language behind that has its roots right here in formal logic. It really was the foundation for all the crazier AI stuff we have now.
But, it wasn't perfect. First-order logic is very black and white. Things are either true or they're false. There's no in between. And the real world isn't like that, is it? It's full of maybes and probablys and kinda. FOL just couldn't handle that kind of uncertainty. And honestly, that's a good thing, because that limitation is what forced researchers to invent the next wave of AI, all the probabilistic stuff and the neural networks we use today, which are much, much better at dealing with all the messy gray areas of life.
So that leaves us with a pretty big question, doesn't it? We saw how a machine can master pure, cold logic, but is that all there is to being intelligent? What about creativity? What about understanding emotion or context? Nailing down logic was this incredible, monumental first step, but it also does a fantastic job of showing us just how much deeper the rabbit hole of intelligence really goes.